Hi everyone, welcome to this lecture. So in this lecture, we will learn why we need activation functions in neural network, why they are so important for the neural network. Now let's understand the importance of the activation function with the help of a XOR gate. Now this is a different from the OR gate. It is called XOR gate, XOR. Okay, so the property of the XOR gate is that it produces 0 if all the input to the XOR gate are similar. If we see the first data sample and the last data sample, the label assigns are 0. The reason is that in first data sample and in the last data sample, both of the inputs are same. In the first data sample, both inputs are 0, and in the last data sample, both inputs are 1. So the property of a XOR gate is that it will give us a 0 if both of the inputs are same. When the inputs are different, that is 0, 1 or 1, 0, we are getting 1 at the output of the XOR gate. So this is the truth table of the XOR gate. Let's plot this truth table of a XOR gate in 2D. So here is the 2D implementation of this dataset or the truth table of the XOR gate. Okay, so when both inputs are 0, that is when x1 is equals to 0 and x2 is equals to 0, we are here. Okay, when x2 is equals to 1 and x1 is equals to 0, we are here. Here we can see that this axis belongs to x2 and here the value of x2 is equals to 1. So this is our second data sample. This is our third data sample where x1 is equals to 1 and x2 is equals to 0. Okay, and this is our fourth data sample where both x1 and x2 are equals to 1. Now, these four data samples are equally divided between two classes, that is 0 and 1. So those data samples which belongs to class 0 are represented here by green color. And those who are represented with the light blue color belongs to class 1. So this is our class 1, this is our class 1, this is our class 0, and this is also class 0. Now the question is there any possibility that we can draw a straight line in order to separate these two classes? So we have class 0 and we have class 1. Can we draw a straight line anywhere in this 2D representation where we can separate both the classes? So the answer is no. For the XOR gate, we cannot perform a linear classification because XOR gate is not linearly separable. Like these two classes these two sample belongs to one class and these two sample belongs to other class. So if we want to perform the classification here, we need something like that, which is a non-linear. We can see that if we draw the classification boundary like this, in that case, these 2 points are on one side of the classification and these 2 points are on the other side of the classification. So this is non-linear classification. In order to perform the non-linear classification with the help of perceptron, we have to make perceptron to learn the non-linearities present in the dataset. That is, in addition to the linear properties, we make our perceptron learn the non-linear properties which are present in the dataset or the non-linear patterns which are hidden in the dataset. So in order to make perceptron to learn non-linear hidden pattern in the dataset, we need activation function. So why we need activation function? Our real world data is non-linear and therefore it is not linearly separable. So we use activation functions to make our neural network to learn the non-linearity and the complexity of the data. So we can see that we can easily perform the linear classification with the help of a neural network or with the help of a simple perceptron. But if we want to make non-linear classification, in that case, we need activation function. So activation function help neural network to learn the non-linearity and complexity of the data. And later on, this will help neural network to perform non-linear classification. So this is the situation for which we require activation function in neural network. Here we have a simple condition where the dataset is linearly separable. Here the dataset is not linearly separable. Therefore, in this case, we need neural network, activation function in the neural network. if we see this equation of the neural network without the activation function, so the equation is W1x1 plus W2x2. So here the output of this neural network is W1x1 plus W2x2. Now, if we compare this equation with the equation of multiple linear regression, then both equations are very much similar. The only difference is if I add a bias term here, then these two equations become exactly equal. Okay, so it is W1x1, it is W2x2. Here we can see that W1x1 and W2x2. It means the equation of a neural network is a linear equation without the activation function. So till now, we have discussed the importance of the activation function, but we did not add any activation function yet in our neural network. And we can see that without the activation function, the output equation of a neural network is a linear equation. So in order to make this equation non-linear so that our neural network can learn the non-linearity present in the dataset and can perform non-linear classification, we need to add the activation function in our neural network. So I hope you understood the importance of an activation function in the neural network. So in this lecture, we learn that the equation or the output equation of a neural network is similar to the linear regression equation without activation function. And without activation function, we cannot perform non-linear classification with the help of neural network. So activation function are very important in order to improve the performance of the neural network. They help neural network to learn the non-linearities present in the dataset so that they can perform non-linear classification. So I hope you understood this lecture. Thanks for listening, and I will see you in the next lecture.